SIM800 Arduino automatic commands. Hello friends. In the last video, we analyzed the manual control of the GSM module by typing commands in the port monitor. And this time we will analyze the topic, SIM800 Arduino automatic commands. The last video blog received a lot of support from you. I am grateful for your every like and comment. I also took note of all your wishes about the following topics. Continue to write your suggestions and questions for analysis in the next issues. In this video, I want to break down two practical approaches to automatically control a SIM800 modem using an Arduino Nano controller. I use both of them in my projects. And in future blogs, I will be based on them, talking about the use of the GSM module. The simplest technology for automatically sending commands from Arduino to SIM800 is simply to insert standard functions for working with the UART port in the program code. I modify the code from the previous video and get the following simple sketch. Everything new here is collected in the loop. The println function is actually the very simple technology for sending an automatic at command. Further, there are additional optional operands, which I entered here only for a visual demonstration of the work of the first working line of code. The println function here receives an at command in string text form and transmits it through the controller's software UART port to the same port on the SIM800 modem. The time delay function divides each sending of this command by 1 second. The next while loop reads the modem's response and prints it to the port monitor, also as a string. We load the program into the Arduino and start the port monitor. We see a response to the AT command every second. You can try to subscribe other commands, as well as several commands in a row. This method of automatically sending commands is useful when we are dealing with commands to which the modem's response is not very interesting to us. For example, after turning on the power, you can send several AT commands in this way so that the SIM800 automatically determines the baud rate on the serial port. Also in some cases, such as sending the text of an SMS message, the simple println and write functions related to working with the UART port will come to our aid in the following video blogs. Therefore, we leave the first example as a note and proceed to its complication for more jewelry work with GSM modules. Let's analyze three canonical functions that are published in many articles describing projects on SIM800L modems. We will study them once, attach them to the sketch, and will constantly use them in future blogs and projects. The main function here is SIM800 command. We will only refer to it directly from the program, and it will already call the other two as its operands are executed. The first argument in it receives a string command to be sent to the GSM modem. The second argument is the expected string response or part of the response if the SIM800 responds positively. For example, the string OK. Here we will enter part of the response line, which we expect to see when the request is correctly triggered. The third argument to the function is the expected string if the SIM800 responds negatively. For example, the string error. Fourth variable to set the timeout for a given positive string or negative. Time in milliseconds. In a simple way, this is called a timeout. And, if you set the expected response strings incorrectly, then the function will spin to a timeout every time it is called. Even when SIM800 has long since answered the request. The last fifth argument contains the number of attempts to send a request with a positive or negative response. And for each attempt, the specified timeout time is given. The return value variable contains the byte value returned by the function. At the beginning of the text of the sketch, we see the declaration of constants. Names are given here for the three types of function responses: OK, not OK, and timeout. Here it will be OK if the first function received the required positive or negative answer. Not OK for this function means exit by timeout after all given attempts. The timeout constant is only used in the second function. The while loop contains the sending of the command text to the SIM800 port, as well as the launch of the wait for function. This cycle will stop after the specified number of attempts or after one of the two expected responses from the GSM module. The function will return 1 or OK if the response is received, and 2 not OK if the timeout has passed for all given attempts. The second wait for function takes 3 arguments, the 2 expected response strings and the timeout. In the do-while loop, the third SIM800 read function is called every millisecond until the allotted timeout expires or one of the searched strings in the response arrives. Next comes the formation of the response returned by the function. This response can be 1, 2, or 3, or in the named constants OK, not OK, or timeout. And the third SIM800 read function without arguments returns the response string to the second function so that it looks for the expected answers in it. The third function checks for data received at the port input and reads them into the reply variable. Further, if this variable really received the text, then its printout to the port monitor for diagnostics is activated. So that we have an idea of what the controller and SIM800 are talking about. Now let's sketch out the simplest program to test the operation of our functions. In the Setup section, a waiting time of 10 seconds after the controller is turned on for self-diagnosis of the GSM module and readiness to receive requests has been added. And in the loop, the SIM800 command function is run every second. Expected OK and error responses. The timeout is 500 milliseconds and the number of attempts is 1. I upload the sketch to the controller and start the port monitor. First, the controller waits for 10 seconds, then it starts sending automatic requests cyclically and prints the answers to them for us for diagnostics. Now let's take a look at the clipping from the instructions for AT commands for SIM800L and get acquainted with the types of AT requests with which it is designed to work. There are 4 types here. They differ in syntax. The first is the test command. It returns a list of parameters that we can change by referring to this command with the third type. In automatic mode, this type is not interesting to us. The second type of command returns the current value of the parameter stored in the SIM800 memory. The third type allows you to change user settings in SIM800. The fourth type is an executable command without variable arguments. For further experiments, I chose the perhaps of little use, but rather interesting AT command AT plus cclk. Here is its transcript from the documentation. It is needed to work with the internal real-time clock of the SIM800 module. The SIM800 chip itself should have an output to the clock battery, but this module does not have access to it and the clock can only count time while there is power at the VCC pin. It shows how the time is set and displayed. First comes the date, then the time, and finally the time zone with a plus or minus sign. Here is an example program for reading the current date time in the SIM800 module. Here, after turning on the Arduino, it waits 10 seconds, then it tries to send AT 5 times before receiving a response from the modem, and then in the main program loop, every second we send a request to read the SIM800 clock. AT command cclk. Positive response OK. Negative error response. Timeout 500 milliseconds and number of attempts 1. The controller first waits for tens, then sends an AT test command, then receives a response from the clock. They show 2004, the first of the first month, sometime, and a time zone of +2. They will always show this way after power is applied. And now let's try to assign our own date and time to the internal clock of the GSM module. The sketch will be as follows. First, wait 10 seconds, test command AT, wait 1 second, read the original date time. Then waiting 1 second and recording your date time. 2021, 12th month, 12th day, time and Kyiv time zone. And finally, in the loop, every second we simply read the passage of time. I upload to Arduino, start the port monitor. We see a wait of 10 seconds, the AT command. Then reading the original time, then a successful attempt to write down your date time. And further in the cycle we see the countdown of the correct time. Since here we see the second, third and fourth types of AT requests, we can say that we have learned to process all three types of commands useful for this mode in automatic mode. And now nothing can stop us from writing sketches for our projects. We also studied a set of 3 common functions for automatic implementation of commands when working with SIM800. Perhaps they will seem imperfect to someone. Write your suggestions for improvement. But I can say that they are quite working, and I constantly use them in my projects. In the following videos, we will develop our skills, learn AT commands. The theme will depend on your comments, and the exit speed on the number of likes. On this I say goodbye, until we meet again.